sugar. I really should say sugars by other names. When we say sugar, we're talking generally about this, the old Domino sugar cube, sucrose sugar. But there's other names. The OSE ending, if you look on food labels or packages sometimes, the OSE ending, our major dietary sugars are glucose, fructose, sucrose, lactose, sucrose ordinary table sugar, lactose milk sugar, and glucose and fructose. You'll see those also. Dissolve sugars in water and you get a syrup. Honey, agave, and maple syrup are examples of syrup, sugars dissolved in water. Corn syrup, very important for our industrial food chain production. High fructose corn syrup, we'll talk about that one also. Starch and maltodextrin. Starch and maltodextrin, they're not starchoses or maltodextrinoses, but you see them on package labels all the time. So what are these? Let's go ahead and look at that. Again, we have our chain of starch. If I extend this chain out, and these are glucose polymer. Starch, if I were to extend this chain out to 200, 1,000 glucose units, a typical starch molecule. The straight chain would be amylose, the branch chain would be amylopectin. These sugar beads, you can take your little string out there too. They're nice because you can pop them into the individual sugar. This is just glucose. You just link glucose together in a long chain and you get the starch molecule. And what's important about this is that this can be broken down, hydrolyzed in water with heat or acid or enzymes to break the starch down into the individual sugar. So the more you cook this and process it and break it up and break it apart, the more available it's going to be as sugar in the mouth. We also have enzymes in the mouth, the amylase enzyme, very efficient at breaking these molecules apart, and then you got sugar floating around on your teeth. So it doesn't say sugar on the label, it doesn't say sugar in a mashed potato or a bowl of rice or corn flakes or the cereal bars or granola bars or whatever, but when this breaks down, stays on the teeth and breaks down, you got sugar on your teeth. So what's the maltodextrin? Oh, the maltodextrin, I could break off, let's say pop off 10 of these. What's interesting is that this is a maltodextrin molecule. A oligosaccharide is smaller than generally what they call a starch or polysaccharide. But you'll see this on food labels everywhere because this is one of those ingredients that's inexpensive. It's a good filler. They just put it in everything. So if you look at your package labels of processed food, you'll see maltodextrin all over the place. Anywhere from 3 to 20 of these glucose units. This falls apart very quickly on the teeth into individual glucose molecules, and you've got sugar on your teeth again. Neat thing about sugar is you can take them apart and you can put them together. What do bacteria do on the teeth? They can use the sugar for energy, just the way we do. You don't need energy. Let's say if we have enough sugar in our system, we don't need energy. What do we do with the sugar? We reassemble it into something like this with branches on it called glycogen as a storage form of sugar. On our teeth, we reassemble it into the extracellular polysaccharide that we're talking about, the sticky stuff that holds the plaque together. So the bacteria use what they need for energy, reassemble the rest as that polymer matrix to keep the biofilm going. If you're playing with your poppins, you can pop a maltose molecule, pop them again, you have glucose, reassemble them into maltose, maltodextrin, put all our beads together and we have a starch molecule. You get the idea. It's all sugar. Okay. Fructose. We got another little pop in our bag. It's not really fructose, so we'll call that one, we'll let that represent, the map is not the territory, but the menu is not the meal. We'll use the nubbly one to represent fructose. 6 carbon, again, we were talking earlier, 6 carbon, you put them together, disaccharide, 12 carbon. Put a fructose and a glucose together, you get sucrose. Sucrose is considered the most damaging sugar for teeth. This is sucrose, ordinary table sugar, and it's comprised of the fruit sugar, fructose, and glucose, which is blood sugar, You put them together, you get sucrose. Why is sucrose so carcinogenic? Why is it so bad for teeth? Because snap your poppins apart, oh, they get energy out of that. The bacteria, the acid germs get energy out of that bond. And then they still have the individual pieces to enjoy. And if they don't need the energy at the time, they can reassemble these pieces into that sticky plaque matrix that we were talking about. So sugar, sucrose, is extremely damaging for teeth. I did mention corn syrup. What is corn syrup? Basically glucose dissolved in water, for the most part, also pieces of glucose. High fructose corn syrup, what do? They hydrolyze, break apart the starch molecules into individual glucose molecules. They take a glucose molecule and with the help of an enzyme convert some of it to fructose. So you have a mixture of glucose and fructose, and industrially it's available anywhere from, they've got HFCS 42, they call it HFCS 95, and that refers to how much fructose is in the mix. Mostly they're using HFCS 55 in the Coca-Colas and products like that. So you're getting the essentially breakdown products of sucrose in high fructose corn syrup, sort of pre-digested sucrose. In your treasure box here, there should be a smooth stone in there that we'll use to represent xylitol. The neat thing about the xylitol molecule is, look, there's no readily available bonding sites on there. It feels nice and smooth. The xylitol molecule doesn't have a highly active or reactive carbonyl group, which is a double bond to oxygen. All the bonds are pretty well satisfied. So the smooth, let's call it the lack of bonding sites, it doesn't fit very easily onto the chain. It doesn't help propagate the plaque chain. The smaller these chains are, the more soluble they are. They break apart more easily. They're not going to cause as much harm. So that's one way that xylitol works. And the molecules, I could pass these around, the difference between a sorbitol and a xylitol molecule. Let's start with our professors here, so if there's a mistake, they can correct it on the way around. Xylitol as opposed to sorbitol. Sorbitol 6-carbon in that same 6-carbon group. All of these sugars, 6-carbon, all our dietary sugars are based on a 6-carbon saccharide molecule. Xylitol is different. Xylitol is 5-carbon. Bacteria don't like it as much or at all. What are high-intensity sweeteners? They're much, much sweeter than sugar. High-intensity sweeteners, example, sucralose, aspartame, saccharin, even certain plant extracts, the stevia side and riboside, I believe, have been recently approved now for use in the U.S. Take out your little packets of artificial sweetener. You have a pink, a blue, yellow. Let's look at look at the ingredients on there. What's the first ingredient that you see? Dextrose. What's dextrose? Dextrose is glucose, D-glucose. Dextrose, same thing. 6-carbon sugar. Maltodextrin is the next one. We just talked about maltodextrin, a short chain of glucose. So if you put that in your coffee or tea, you're sipping on a sugar solution. And we talk about the number of exposures you get to sugar in the course of a day. I think most people believe they're being sugar-free if they use these packets. They're not. They're still sipping on a sugar solution when they put these in their beverages.